Hello everyone, welcome back to my channel Cat Voyager. This is me Mayanka Chattopadhyay and this is day 17 of our series of daily QA problems. The question on your screen is from CAT 22 slot 1 paper, and this particular question is from combinatorics, and this is perhaps the first time in our channel we are going to solve a problem on permutations and combinations. So let's get started. The question is saying that the number of ways of distributing 20 identical, this word is very important, identical balloons among 4 children such that each child gets some balloons but no child gets an odd number of balloons. Okay, we will come to this part of the problem, this odd number of balloons, this part of the problem later. But let's first understand how can we represent this problem in another form, or I will give you another way of asking the same question. Okay, so notice that these balloons that have been mentioned here are identical, but the children are distinct. Obviously 4 children are distinct here, right? So another way of looking at this problem might be, suppose A, B, C and D are your 4 children and they are going to get 20 identical balloons. So we can write A plus B, the number of balloons at A, the number of balloons at B plus C plus D is going to be equal to 20, right? This particular question can also be asked in this form, that find the number of positive integral solutions of this particular equation. These two questions are one and the same. Positive integral solution means A, B, C and D all are going to be greater than or equal to 1, and also another condition is this one, that A plus B plus C plus D is going to be equal to 20. This is a very common type of problem, and most probably you will encounter these kinds of problems a lot during your mocks. So let's try to first derive. There is a formula obviously, but first let's try to derive the formula. So we will go by some method which is known as balls and sticks method. Okay, so let's first understand what this A, B, C and D represent. We can think of them as buckets. This is your A bucket, this is your B bucket, this is your C bucket and this is your D bucket, and you have 20 identical balls or balloons and you have to put them inside these buckets in such a way that the sum of these 4 buckets become 20, right? So let's generalize this thing. Let we have n number of identical objects and we have m buckets. Okay, in this question n is 20 and m is 4. So if we have m buckets, let's say this is a bucket, this is a bucket, this is a bucket, and like this we have m buckets. So how many gaps will we have? If we had 4 buckets, the number of gaps would have been how many? This is 1 gap, this is 1 gap and this is 1 gap. So 4 minus 1 equal to 3 gaps. So similarly in the case of m buckets, we will have a total of m minus 1 gaps. Okay, we can think this m minus 1 gaps as m minus 1 sticks. M minus 1 sticks. So let's suppose we have 6 such sticks. I'm taking an arbitrary number. If we have 6 sticks and we place them on a flat surface like this, 5 and 6, so how many buckets we are having? We are having 1, 2, 3, 4, 5, 6, 7, right? And suppose if we had 10 number of balls, again an arbitrary number, 10 number of balls, we could have put them like this. Here 2 balls, 1 ball, 2 balls, no ball here. We will have 3 balls, 1 ball and 1 ball. We have 2, 1, 3, 5, this is 8, 10, right? So this is a possible solution of this kind of question. of this kind of question. The only thing was that in this question we had a1 plus a2 plus a3 plus dot 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 a7, total of 7 buckets, and the number of identical objects in this case were 10. So this particular equation can be represented in this form. Or we can also think this thing like this, that we had suppose 10 balls, 6 7 8 9 10, suppose 10 balls, and how many sticks we had or how many gaps we had for this 7 buckets. The number of gaps were 6. So we can place this 6 sticks anywhere within this flat surface. So maybe we could have done 1 stick here, 1 stick here, 1 here, this is 4, this you have 5, and this is 6. This is a possible solution. So 2 and 1, this is 0 because nothing is between these 2 sticks. Here it is 3, this is 3 and 1. So we have 3 plus 3 is 6, 1 7, 8 and 10, right? Or we could have also have another arrangement like say this 1 stick here, 1 stick here, 1 stick here, here, and 1 here, 1 here. So in this case we have what? 2 0. For this we have 4, this also 0, this is 2, 1 and 1. So if you add these things up, you will have 4 6 8 9 and 10. So depending on the position of these 6 sticks, we will get the number of balls or balloons in these buckets, right? So this bucket is nothing but your a1, this is your a2, this is your a3, this is a4, this is a5, a6 and a7. So depending upon this position of these sticks, the values in the buckets actually change. So we will try to arrange all these balls or balloons and sticks in a linear arrangement and try to find how many different combinations we can get from this arrangement, and that will be basically your number of solutions or the number of all possible arrangements. So let's go back to our parameters n and m. N were identical objects, and we had m buckets, right? So for m buckets, the number of gaps or number of sticks will be m minus 1 sticks, right? Now also notice that as the n objects are identical, this m minus 1 sticks are also identical, because sticks are not distinguishable from one another. The only distinguishable thing here are the buckets. So depending upon the position of this m minus 1 identical sticks, we will get m distinct buckets, right? So what do we have? We have like this total n identical balloons. These are n identical balloons, and we also have m minus 1 sticks somewhere between them. This somewhere between them, this m minus 1 identical sticks. So all together, what do we have? All together, this is similar to those kind of questions where we used to see ki we have a word, suppose banana, and they asked what are the different number of arrangements possible for this particular word. We used to look at the number of similar and distinct objects, right? So we have 1b, we have n, 2 n's, and we have 3 a's, right? And total, this is 1 2 3 4 5 6 letters used to be there. So the number of possible arrangements we used to do were 6 factorial by divided by the number of the similar things. So you had 3 factorial into 2 factorial and into 1 factorial is 1. So this is to be your answer. Similar things are going to happen here. We have total how many objects? Total objects including our n identical balloons and m minus 1 identical sticks are nothing but your n plus m minus 1, right? And among these many objects, how many are identical? N identical balloons, n balloons are identical, and m minus 1 sticks are identical, right? So what will be our all possible arrangements? It will be n plus m minus 1 factorial by n factorial into m minus 1 factorial. This particular thing is nothing but n plus m minus 1 c. C stands for combinations, or it is also known as choose. So n plus m minus 1 choose m minus 1. If you know, this NCR formula is given by n factorial by n minus r factorial into r factorial. Similar thing is happening here also. We have this factorial here divided by this m minus 1 factorial and n plus m minus 1 minus m minus 1, which is also n factorial, right? So this is the formula of this kind of questions. Okay, now for this particular thing we have considered that the sticks can also be placed like before the balloons or after the balloons. So in this case we could also have a bucket here and a bucket here, or we are having sticks in between these two simultaneous sticks. So in case of this particular bucket, we were having the number of items in particular bucket is 0. Here it is also 0. Here it is also 0. That means there is a possibility for this case that the number of objects in that particular bucket may be 0. So basically in the cases of this particular things like this A7 equal to some n, if they ask non-negative integer solutions, that means your ai's or a1 2 3 4 this can be greater than or equal to 0. In case of this non-negative integer solutions, you can use this particular formula, because there is always a possibility that the value of a1 or a2 or a3 might be 0, right? Now what happens if they ask us that the solutions are positive integral solutions or natural numbers? So in that case your ai should be greater than or equal to 1, right? So in that case you cannot use those formula, because if you use them you will get more number of solutions, because 0 always is a possibility in case of using this particular formula. So let us try to modify this particular thing into something which we already know, that is this one. So let a1 can be denoted by m plus 1, a2 can be denoted by n plus 1, a3 can be given by p plus 1. Similarly we have q plus 1, let I plus 1, j plus 1 and k plus 1. These are nothing but your a1, a2, a3, a4, a5, a6 and a7. What are this? Why have we taken this in the plus 1 form? Suppose our m becomes 0, then the value of a1 will be what? 0 plus, sorry, then the value of a1 will be what? 0 plus 1, which is also equal to 1. So in any case when m is m or n or p, these things greater than equal to 0, our a1, a2, a3 will always be greater than equal to 1, which satisfies this condition, right? So we are transforming actually this particular equation in such a form that we can use this particular formula. and arrive at another result. Okay, so what do we have from here? This particular equation becomes m plus n plus p plus q plus I plus j plus k, plus we have how many ones? 1 2 3 4, like this 7 ones, right, is equal to your something n. So from here 7 will go on that side, so m plus n plus p plus q plus I plus j plus k equal to n minus 7. Notice now what has happened. Now what about these values of m, n, p, q, I, j, k? M, n, p, q, I, j, k, these values now can be greater than or equal to 0. So it is safe to apply this formula in this particular case. So we are looking for basically the number of solutions of this particular equation, and that is similar to number of solutions of this particular equation when our ai greater than or equal to 1, or positive integral solutions. So positive integral solutions of this equation is equal to non-negative integral solutions of this equation. So what will we have? We have how many terms? 7. So our number of solutions will be n minus 7 plus m minus 1. What is your m? Your m is 7 minus 1 is 6. Choose. This is your m is 7, so this will be your m minus 1, which is also equal to 6. So this becomes n minus 1, choose 6. Or if we write in terms of m and n, this will be nothing but your n minus 1, choose m minus 1. So we already got two formulas. If they ask non-negative integral, all these words are important, integral solutions of an equation given in that previous form equation, and the terms are a1 a2 dot 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 am equal to sum n, then the number of solutions will be n plus m minus 1, choose m minus 1. And if they ask positive integral solutions of an equation in similar form, in the form of a1 plus a2 plus dot dot plus am plus equal to n, then the number of solutions of this particular number of positive integral solutions of this particular equation becomes n minus 1, choose m minus 1. By intuition you can see obviously this thing is greater than this one because zeros are included in this case. So now let us come back to our problem. What was the equation we first wrote? The equation we wrote was, this is a plus b plus c plus d equal to 20. So what do we have? A plus b plus c plus d equal to 20. Fine. Now let's look at the conditions that has been mentioned in the question. They have mentioned that each child gets some balloons, but no child gets an odd number of balloons. Fine. That means what can you tell about the values of a, b, c, d? These values of a, b, c, d has to be greater than 0 because every child has to get some amount of balloon. And also they have mentioned everybody got even number of balloons. They have mentioned that no child got an odd number of balloons. So this a, b, c, d can take values which are nothing but 2, 4, 6, 8, 10, like this and so on, such that this equation satisfies. So our goal is to always take this particular equation in such a form so that we can comfortably apply this formula or this formula. So let us modify this equation. Let a equal to some 2m, b equal to some 2k, this is your 2p, and this d is your 2q. So our new equation becomes this 2m plus 2k plus 2p plus 2q equal to 20. Why have we taken in this form 2m? Because whatever value you take for m, k, p or q, this a, b, c, d will always be even, right? So if you take 1, this a will become 2. If we take 2, this will become 4, and so on, like this. So we can also write this m plus k plus p plus q into 2 goes common, equal to 20, or m plus k plus p plus q equal to 10. Now what about the values of m, k, p and q? Can they be 0? Can m, k, p and q be 0? They cannot be 0. They cannot be 0, because if they become 0, this a, b, c, d will also become 0, and that violates the condition of our question that every child has to get some amount of balloon. So obviously these things has to be greater than equal to 1. So what we are looking for? We are looking for this particular formula, positive integral solutions of this particular equation, right? So we have how many buckets or how many variables? We have 4 variables. So your m is equal to 4, and what is your n? N is equal to 10. So the number of solutions will be 10 minus 1, c, 4 minus 1, and this is nothing but your 9c3. And if you evaluate 9c3, it will become 9 factorial by 3 factorial into 6 factorial. So you can write like this: 987 into 6 factorial by 3 factorial into 6 factorial. This goes out, and this will become 3 into 4 into 7, or the number of solutions are 84. This is the answer to your question. The question asked us the number of ways of distributing 20 identical balloons among 4 children. So the number of ways are 84. So guys, this was a very good and common question. You might encounter them similar questions in your mocks, or it might even come in your actual exams. The important thing in this problem was to know why those particular formulas, those n plus m minus 1 c m minus 1 and n minus 1 c m minus 1, actually how we arrive at those particular formulas. Instead of just memorizing them, it is good to know the derivations of these particular formulas, because then only you will understand when to apply these formulas in particular questions. And by looking at the questions, you can also understand the constraints, and accordingly you can decide which formula to apply and how to modify the equation such that it becomes easier for these formulas to apply. Notice also that this is a special case when we try to distribute n identical objects to m different identities or m different buckets. These things will not apply in case of problems where they ask for n distinct objects. If this identical becomes distinct, then things will become something else. You can think of this particular problem when they ask for number of integral, positive integral or non-negative integral solutions of these equations. This n you can think also as collection of n ones, right? So n is equal to nothing but n into 1. So this 20 or this n is nothing but collection of 20 identical ones or n identical ones. That's why in these particular problems it is applicable that we are actually distributing n identical objects to m different buckets. If this combination changes, this identical and different, this combination changes somehow, then these formulas would not be applicable in that case. So first you carefully go through the problem and only then you decide whether to apply this formula or not. First build the equation and according to your question modify the equation such that these formulas can be applicable, if applicable at all. So guys, that was our problem for today. Hope you liked and enjoyed the video, and if you learned something from it, please don't forget to like, share and subscribe. Share this video among your friends so that they also can learn something from it. This is a very important concept that comes a lot during your mocks or might appear in your actual exams. At the very end of this video, I have also attached a playlist where I have included all the previous videos I have made so far. If you have not already, I would definitely suggest to please go back and have a look at them. They contain good problems and they will surely reinforce some of the basic concepts you are having. If you want me to make videos on any particular topic, please reach out to me personally, or you can also drop a comment in the comment section of this particular video. Thank you for watching, and hopefully I will be back with another such video. Until then, stay tuned. Bye bye.